Okay. So recording it, I will change that to here, and okay, just basically like this. I think sorry, it's a little bit crowding here, but basically you can see it's just very similar with your Windows surface here. Let me close this. Okay. So firstly, what it look like is like this. A little bit different with Windows, but I think it's the same. You can see that in the left, in your left, is a current folder. Current folder. This is show all the files you have for the MATLAB. So this is just same, yeah, with you can see the lecture, web class. Web class に、と同じようにですね、左側に現在のフォルダの部分になります。ブロックになりますね。And this part is command window. In here, we just input a lot of things. You can know it later. And your right, it will be the maybe somewhere else. In my case, it's right in the right side. It's workspace. You can see it here. If you drag them up, workspace. All your variables will showing here. This is for convenient for your debug. Okay. ここに少しよく問題があるのは、Windows をここをクリックしてしまって、どうになったか分からなくなるという問題があります。例えば、こういうふうになったり、こういうふうになったりすることがありますね。So basically, you can adjust the position of this block to there and there, and even change them to a different position. Okay, you just try to find a proper place for them. Okay. Sometimes just try. Okay. Oh, here, this is a command history. You can see what I did in the last time here, or what you did in last time here. All the blocks is movable, so when you use your mouse, so please be careful. If you cannot find it, you need to you can find it actually. Let me see. Environment layout, please. You can find it here. Environment and layout, please. Let me see. Let me try to find it in the Windows. Here is layout, and it will show you what you have here. Okay. If you cannot find my folder, current folder, then you click this one. If you cannot find workspace, click this one. Okay. Sometimes you just lost your window here. So in that case, you just go to home. Maybe too fast. Home, and here is environment block. Then you click workspace. Then you just try it out and find out what is correct. Maybe you can find it trouble later, but we'll deal with this later. Okay. よくあるのがWindows が消えたりなくなったり、あるいはレイアウトがめちゃくちゃになったりですね。よくある問題ですけど、その時にまた、調整できますので、できるだけ今は、そういう調整をしないようにしましょう。それは一番無難な方法です。Okay? So, until here, I think there should be no such big problem. And now we start to use our keyboard. Okay? We just do what we do in the file. A equals 1. So A will be a variable. 1 is an integer. Okay, if you do that, push enter. And in the screen, it will show A equals 1. A equals 1を入力したら、A equals 1になります。と表示があります。 Also, you can see in workspace, there was empty there, but right now I have A. So if you double click it, it'll show up equals to 1. Actually, it's crashed your workspace here, so I just find it out. Okay. But you can see that there's a variable A equals here. Here's the value. Okay, let me just hide it. Okay, you can try by yourself when I'm explaining it. Other things there. B equals true. That's B here. If you click it, and you can see that B equals true as it is. Okay. Okay. So most of you did it successfully. Then we go C equals to, now we just give a variable a value, a true value. Of course, if you give a already exist value to exist value, and you will change another. But right now we just use two of them. A plus B equals C. That's 3, right? No surprise. Okay, so you can give a definite value, but you don't need to say that definite C equals to 3. Okay, you just use the equation, then it will automatically generate it. So it's different with Fortran, with Basic, with C until right now. It's just very dynamic, generate variables. We will need it. 今までのプログラミングで言語はまず変数を定義しないと実施できないですね。最初にはディメンションだったり、インティガーだったり、まず定義して、こういう変数はどういう変数なのかを定義してから、この変数に値を当てることが可能になります。ただ、MATLAB では常に勝手に使えばいい。特に定義する必要はなく、パソコンは自動的にこれをどういう変数なのかを判断していきます。もしそれもダメだった場合にエラーが出てきますけど、エラーがロジック的には不可能の計算になるまでは常に新しい変数の定義が出てきます。これは MATLAB の便利なところですね。So next, let's use some very basic function of MATLAB. MATLAB have a lot of mathematical function inside. For example, we use sine function. You can get sine A equals 0.84. MATLAB では、たくさん、数学の関数が中に入っておりますので、便利に使うことができます、もっと詳しい情報は後でインターネットから見ればわかると思いますが、例えば、 So if you try to search internet for the function, I just go to the basic. Sorry, not the function, the mathematic MATLAB. Okay, let me change it to English. If you go to see the mathematics of MATLAB, then you can see a lot of mathematic basic functions that you can use here. Even Fourier analysis and filtering. Okay. フリ変換も簡単にできるということですね。基本的な数学の関数ですね。Okay, as you can see that there's a lot of function that you can use very simply, like sine, cosine, sine, something like this. All of this you can use very conveniently. Okay. So let's try another variable. E equals a multiple b. We just use plus and then we use multiple. Okay. So no surprisingly, it becomes true. Okay. So just like this, we have the basic of calculation. Okay. Until now, all the variables and functions are just a single value. Okay. But the most advanced feature of MATLAB is doing matrix calculation with vectors and matrix array, something like this. So next we'll go to the array part. So actually MATLAB is just as its name, it's a matrix laboratory. Basically they're doing matrix calculation. 今までは一つの変数の計算を繰り返していますが、マトラブというものは実際にマトリックスを計算するための道具でありまして、特にマトリックスとかベクトルの計算が強みを持っている道具であります。So let's see how to create an array first. Just okay. Let me clean all the things I've done here, so make the screen clear. So I just say CRC. Okay. So the command window becomes clear. Okay, because I cleaned everything, so you cannot see CRC. So if I CRC ボタンを押せば、コンソールクリアという意味で、コマンドウィンドウのすべてを消していきます。CRC ですね。さらに、in memory, we have a lot of things in the memory, so we want to clear all the memory in the space, workspace, so I use clear. And let's see our memory is clear. CRC again. That's it. It's just like a white sheet. So start again. Oh, okay, let me check. Check out. Beautiful. Okay. So maybe you just did the CRC thing very good, or you just didn't do anything until you came here. Okay. So let's do the array thing. So a equals to 1 with a bracket, square bracket, 1, and with a space, 2, another space, 3, another space, 4, and bracket. Okay, if you enter, you can see a variable which is array or matrix or a single digit matrix. You can check it out from the workspace. Okay, no problem. Safely here. Okay. So it's vector. So how about the matrix? Again, 1 space 2 space 3. here I use semicolon. So this means change another column, another row. And we'll see 4 space 5, 6, semicolon, 7, 8, 10. Okay, matrix like this. Change another row, and 4, 5, 6. You can see we change the semicolon here. So space means different cell, and use semicolon to change a line. Okay. So also there are a lot of tools that can conveniently create a matrix from some basic matrix that don't you need to input every single cell of matrix by yourself. Okay, consider you have 144 100 matrix and you need to input them by hand every a lot of time. So there's a function that help you to create matrix variables very conveniently. So for example, a 0 vector or matrix that all of them cells are 0. So I don't need to input like z equals to 0, 0, 0, 0, 0, 0, 0, something like this. I don't do this. I just do 0 equals a function of zeros. Now be careful, there's a s there, zeros, not single zeros, with a circle bracket. Circle bracket means that here is a function. A square bracket means here is a matrix. Okay? すべて0を入力せずに、zeros という関数を使いましょう。ここには円括弧を使います。四方形の括弧は、角括弧はマトリックスを意味して、円括弧は関数を示している。括弧の中には変数を記入します。5列1行の5行1列の関数を書くというところです。もちろん。So, okay, there's no trick. If you use up arrow, then you can call all the function you have done before. Okay. So I just try to use 5 or 50 multiple 50. Okay. 30 or 50. Okay, you can count for it, but I can promise you that it's 50 to 50. Okay. Also, let's do something that more, you remember what is is, right? Here, a is here, like this. And what if I plus a 10 to every cell of A? So I just use A plus 10. Okay, is a matrix plus. Matrix plus instant value, constant value, not a matrix, but one single value. Then it will be plus to all the cells of them. Okay. マトリックスの足し算をしましょう。マトリックスを足し算するときには、マトリックスプラス定数の場合には、マトリックスのすべての要素の中に、それぞれこの変数を足し算することになります。もちろん、掛け算するときにも同じです。では、10×A の場合には、もちろん10と11になります。Okay, let me try. But here still I have A is here. Okay, A is still here. So if I try A over 10, still you can see this. Okay, you can try all the time, but I will show you if we use sin A. Okay, until your command is B equals A multiple 10, and B becomes that. But after that, it will be only give the result to answers. Okay, you give to answers if you say ANS, the answers. It was a special variable that didn't show in the workspace, but is in the memory. But once there's another answer comes out, that will be overwriting. で今は特に先にやってる演算は特にある値に与えた、ある変数に与えたわけではなくて、例えば b イコール a プラス10の場合は、b はこうになりますけど、今のうちにはどの変数にも当ててないので、特別の変数 ANS ですね、答えに結果を教えます。ただ、毎回の計算は answers という変数は更新されますので、上書きされます。特に保存されませんので、この点には注意してください。まあ、一番最近の結果を示すだけです。サイン関数の計算にもなります。まあ、普通には難しいところですけど、So you can make your matrix as a variable, as a parameter, give them to a function. The function uses this matrix to calculate for you. And they will automatically know what is the function, what is the vector, what is just a value. Okay. There is also a very convenient function, invert A, which give you invert matrix of A. A の逆行列を計算する場合には INV 関数を使いましょう。非常に便利な関数ですけど。So just in case you don't know what is an inverse matrix, I don't think so, but just multiply them, it becomes 1. Okay, just in case. Okay, when you see it, you see a lot of 0 here. What if I don't want to see too much 0 here? So I just use format. So it will change format of all the display. Short. もしフォーマット、つまり今表している変数の結果のフォーマットの表現を改めたいですね。見た目を変えたい時にはフォーマット、ショートを入力すると、ケラスはそんなに多くのケラスではなくて、もう一回 P をすると、こうなります。A 自体はこれなんですけど、P は、P は A ドット掛け算 A となっています。A ドット掛け算するときには、要素ごとに掛け算していく。最初の A は 1×1、1×1×1。で、2×2 は4になります。3×3 は9になります。つまり、すべての要素の事情になります。So we use here A dot multiple start A. It means that it's a basic multiple calculation. That means the matrix element multiple the according element one by one. Okay, do not do the matrix multiple calculation. Okay, so of course you can try the general way. You can try A multiply A. This is matrix multiplication. Okay, this line multiple this array. Okay, and get rid of 30. This is a matrix multiplication. もちろん行列間の掛け算にもドットを使わずにできます。ただここにはまず簡単な要素ごとの掛け算だけを実施したい。Sure, you can try the dot, okay, heart, let's say 3, okay, so square. 3乗、要素ごとの3乗になります。勝手に行 行列を拡張することもできます。A and comma. Okay. Okay, you can see this is A here. There's another A here. Okay. Even you can do A here. And here's A here. And put another A down here by a semicolon. Consider you have a lot of A is a block of matrix. You just one block and change another column, another block. Okay, the last one for this sequence will be complex number. That's one. Okay, SQRT means square root. Okay, if you minus a square root, it's going to be an imaginary number. Okay, it will show like this. Okay, so let me clear again. So before that, see. Yeah. Remember this is a Japanese keyboard. Okay. So this first time, so I think we just take our space very slowly, and so everybody can catch up. And okay, as I mentioned earlier, we have a lot of way to create a very large matrix very easily. We introduced about zeros. There's another one. You call it magic. Even very complicated matrix. Some 4 multiple 4 magic matrix. Okay, you can see that this line plus together, this line plus together, it will be all becomes one single result. And here is 24, I think. No, 34, sorry. Okay. And we can just focus on the one single element inside this large matrix. For example, 4, 2 means 4 line, 4 of the row, and the second column. Okay, means 14. 4 the fourth row and the second column. 4, 2. This input is coordinate, and this specific element inside the array will come out. And also, I want you to realize that inside the matrix of MATLAB, all matrices are basically just array, but with different columns. Inside a matrix, they have two types of numbering. One is which row and which column, like 4, 2. Another is just a single number. We count from the first left up element. This is the first one, and with a column 1, 2, 3, 4. And that next is from here 5, 6, 7, 8。マトラブの中では、基本的にマトリックスでもアレイとして処理している。つまり、2つの表現の型がありまして、1つはマトリックスの中の座標位置をどの行のどの列の要素であるという表現の仕方と、もう1個は全体的なナンバーを言うことができます。つまり、すべては縦方向の列からのナンバリングします。一番左上の方の要素は1番の要素で、その下には2番、3番、4番、1番、2番、3番、4番。で次は、列を変えて5番、6番、7番、8番。で、9、10。順番にやっていきます。なので、ここには同じく8で入力する場合には、特にここにコマが入らないですね。So, I don't have a comma here. I just input number 8. The studio becomes 14. So it means that we just give them one number. The MATLAB will know that, oh, you want to use this kind of numbering, just use total number. Okay, I give you the 14. Okay. We can directly give another variable from a matrix. Oh, we cannot give that because we don't have the 4 and 5. We only have a 4 multiple 4 matrix. We don't have the element of 4 or 5. But we can give them a number. 4 and 5 equals to 17. So you can see that they will increase another column, then put a number here. So that's why we call the MATLAB dynamic language. Means when they run in the program, it will changing the size of your variable when it's necessary. But of course, you cannot give them a number that's out of the size of the matrix. ここではA の4、列第5行5列の要素を他の変数に与えようとしたら失敗しましたですね。エラーが出てきました。問題は、4、5要素は存在しませんという結果が出てきます。インデックスは境界を超えました。というものです。A のサイズは 4×4 です。ここにサイズも一つの非常に重要な関数がありまして、マトリックスのサイズを教えてくれるんです。ただ、範囲外の結果をこの関数に与えることができます。この場合には、新しい列を作って、最小限のサイズを拡張して、このスペースを確保して、値を入れることが可能になります。So let's see what is the size of A right now. It's 4 minus 5. Okay. It's very convenient function that can confirm what the size of the matrix. Okay. There's also a very convenient command that you can create a very long array with a linear array. Just use clone. For example, 1.2 or 5 or 100. Okay, so it's very easy. I can just say it. Okay, here also you can combine it with use this to find out the variable of in the matrix. So what does this means is means the 1, 2, 3 rows in the second column. Okay. In this range number, please tell me the number in this range. What it gives you is a vertical direction array. ここで一つの便利な列を作る関数を紹介します。コロンを使えば1から3までですね、あるいは3から4までですね、任意の行列を作ることができます。質問としては、100から1まで作ることができるんですかっていう質問も出てくるでしょう。ここで少しやってみましょう。できないというところです。1から小さい変数から大きい変数にやっていこうと。でこれを利用して先にA の、1から3までで、コマ2っていうのが1から3の行で、2番の列の値を示してください。あれは提出してくださいという命令になります。Okay. 独立に関数のインデックスとしては、コロンを使うときにこのすべての列あるいは行を示してください。という意味で、now we use, if we use column here, this means that all the things in this row or column, if you right side as a column, so all the column of this row, of the third row, will be shown out. Okay. Also, we can use create array with a constant interval like this. In the middle of them is a start from 0. Interval is 10 until 100. Okay. So if you're not 100 exactly, you have 101, and still you'll go 100. But not go over about it. Of course, you should 99. You'll go to until 90. Okay. We're gonna try about it. You can use this, try, okay, from 0 to 100. There are how many? 13 there. You can get there. Okay, I don't. Let's see, size. Okay, 13. Let's see, 101. Be 8. Especially when you press 1, be careful because instead that you change the character. Okay, so let's go next. Okay, again, let me clear everything and also the console. So we can, until now, we just show everything in the command window. But sometimes we don't want to show everything that in front of me. So I will use way that only that show them in the workspace, not in front of the command window. What I did just use semicolon here, and nothing showed. Okay, if I don't use semicolon, it becomes like this, right? But if I use semicolon, then it will not showing up. Okay, I'll do it again. Okay, I becomes here, and B becomes let's say random. Random is just a random function. You pick up numbers randomly. What I'm input here is only the size of the function. From number from 0 to 1. Okay. You can check out of the workspace. You can check out workspace here. A is when you double click it, you can see what's inside them. Okay, when B double click it, you can see that because that is a three-dimensional matrix, so it will showing in the columns like this. Okay, so I got this. Okay. And even you can save it to a file. So before that, I will create a folder to save all of my things I do today. So I create a new folder here, 7, new folder, say 1, because it's first lecture here. I'll say save my file .mat. My file part is free. You can save anything, any name you like. But save is a command here. Okay, save is a command here that you need exactly input here. But this you can change, customize yourself. MAT is a fixed extended name for the special format of data. So you cannot change it. So you just put it. And you see here, there's a new file here, my file, MAT. Okay. So I want to clear everything. So in workspace, there's nothing here. I put A, give me nothing, right? Then I just use the command of load my file, MAT. But in this time, this file name from here to here, you should be exactly same with the file name we are already here. Okay. Then all the data saved is come back. Okay. Again, I just clear it, or I just double click it. It also comes up. Okay. Yeah. Sorry. Magic matrix is a very special matrix that every line, every column, or the diagonal direction, you plus every element together, sum them together, it will become the same number. It's a magic matrix, right? This means every column, every row, or diagonal direction, you multiply all the numbers together, all will be the same. Okay? It's kind of a beautiful mathematics, okay? Or you can use it as a tree. 先に幕行列というもの、マジックというものが使いまして、ああいうところはどういう意味かというと、行 要素ごとに退散すると、列の要素のごとに退散すると、斜め対角線に退散すると、すべては同じ数字になります。Okay? You can show, okay, I cleared it. So I just click it again. It comes out. Say what is A? Okay. We multiple this together. So how to multiply them? Let's use sum. Okay. 1 of A. 1 the first line. No. Okay. 34. Of course, you can count it by yourself. Okay. Sure, I'm not stopping. But you can try every row, every line. Okay. So I didn't teach you about sum, but I think you can figure it out. What is sum? Yes. Because we didn't save my order, the first use need to save your file before you load it. Okay. So okay. Now you don't have anything in your memory. So you firstly you need to create something. Okay. So for how about try A equals magic? Yeah. Clear everything. Just say A equals to magic. You need to add J here. Jesus, not J. Yes. 5. 4. Okay, it's just 5. Okay, so you can try to save it. Now you can see it here, right? Okay, then clear it, and we can load it again. Yeah. Now you can load. Okay. Okay. Now I think today you really learned a lot today. But still, we have a little bit more to go. Firstly, let me clear everything, and let's go to the text. Okay, array or string. Here until here is same thing, right? Where we learn to do the same thing, but we need to use the code, single code. Okay, between the two code, we just input hello world, and with a semicolon here. Then you can see in the right side you have hello world variable, and other text. Just try. You are right, but if I use general code, then it will add some error flag. So I just use double quote. Okay. If you use quote inside the quote, then you need double it. Right. So it comes out. You're right. And this is a funny function. If my text use whose, then you can see the more detail about this variable. It tells you the name, and the size, and the bed, all the property of this variable. Also, we can connect them together. Just consider every character is a single element in an array. So the first block, my text, and the second one is a dash, other text, another one. So we just pick them just like A, space A, or sigma A, something. Then it becomes like this. Oh, I think I need some space here. Even space I'll count it here as a variable, so you can see the difference. And you can combine string even with some other variables. For example, I like 51 degree of temperature, and we change them to C in the unit of C. I think it should be, there's an equation F minus 22, 1.8 to Celsius. So you can see what is Celsius. 21 is a very comfortable degree, right? And the temperature text, I would like them to equals to temperature this is a string, and number to string. This means we change number to string. Okay. Temperature is, oh, we maybe have some space here. I just use the up arrow to call them up. Okay. Okay, so right now is a time, but let me just show you very fastly about how to plot them in the two-dimensional. Very fastly, maybe too fast, maybe. 0 to, okay, pi, if we use pi here, it will automatically know that is equals to 3.14. Okay, and more, of course. 2 pi, it means that we are increase a vector from 0 to 2 pi with 100 pi interval. Okay, you can see that. And y equals sine pi, which from 0 to 2 pi, of course. I use semicolon, so do not show all of them. I'll show plot x, y. Okay. I don't need semicolon anyway here, and shows up the plot. Okay. X is 201. X is a 201 matrix array here. Y is not a 201 array here. Okay. Then we just show them up together. Okay. If I say y 202 equals 0, and we call the plot again, there'll be arrow, because two of the array should be the same size. Or I should say that 202 equals 0. And plot them again. Then they will show up like this. Of course, count back to 0, because the last one is 0. Okay. So of course, other things that we can put them inside the frame here. Okay. scaffold a little bit. And I can show the, I can show the X label. That's X. Okay, you can say X comes here. And Y label Y. Sure. Oh, sorry. Sin X, not Y. Sin X. Okay, you can see here. This Y label comes up here. Titles of plot of the sine function. Okay, titles come up here. Okay, and figure 1 becomes larger. You can see it in the full size, or not, or something like this. Okay, so even you can change them. You can change them. Plot X. I say 1 to 201. Okay. This means I don't want this part, the horizontal part, and Y 201. Okay. With string of R dash dash. Okay, what mean R dash dash means? It becomes like this. In red, in color, and dashed line. Okay, broken line. And you can even, sure, why not? Let me just reclaim X equals to X 1 to 201, Y equal to sine Y1 equals to sine X, Y2 equals cosine X. I just save it and then show it up. And okay, I just clear my flag figure with CRF, and we'll plot X Y1. Okay, and I will say, hold on. Maybe I say later. Hold on, I will put another plot there. X dot Y2 with red colon. Okay, and with legend sine cosine. So the first one is the first plot, and second the second plot. You can see the legend comes up here. Okay, let's see the 3D plot next time, maybe. Okay, I want to put out two more things in your brain. Okay.